Hi, this is Maggie. In this video we're going to talk about the syntax of functions. A function is a block of code that has a name. When you use the name of the function in your program, the code executes. Functions can take data as inputs from other parts of the program, and a function can return a result. We've used functions from the Python libraries. For example, we've used the random.randint function, which has all of the properties I just listed. It has a name, randint, and when we use the name, the code executes. We did not write the code, but some industrious Python developer wrote code to generate a pseudo-random integer. It takes two input values, the minimum and the maximum of the range. It returns a result, the pseudo-random integer within the range. The randint function is a component we can plug into our program when we need a random integer within a specific range. Let's write a program with a function so we can go over the syntax. Suppose we want to write a program that will obtain two numeric values from the user and determine which is larger, or whether they're equal. We'll write a function to do the comparison part. I'm going to begin by writing a docstring. Compare two numeric values obtained from the user and then annotating some variables. We'll have num1 and num2, and we can just make them integers. But they could also be floats, and we'll have the result of our comparison, which will also be an integer. Now I'll write some code to obtain the numbers from the user, which is just an input statement, casting the result to an int and assigning into my variables. And now I want to compare the values. Well, I'm going to put that in a function. So here I'm going to invoke the function. I haven't written it yet. We'll do that in a minute. But I want it to be called compare because that's what it does. It compares. And I'm going to pass both numbers to it because those are the values I want it to compare. And it needs to return the result to me. So I'm going to assign the result into the variable comparison. This looks a lot like generating a random integer. Functions don't always take two arguments to work with, but that's what makes sense here. And when functions return a result, we need to assign that result to a variable so we can use it, or otherwise use the result by embedding the function in an expression, as we have done with some of the math functions. I expect comparison to be a positive number if the first value is greater than the second, a negative number if the first value is less than the second, and otherwise 0. So if I want to report that to the user, I could use an if statement here. If comparison greater than 0, print first number is larger, elif comparison less than 0, print the second number is larger, else print the numbers are equal. Okay, let's write the comparison function now so we can run this program. I'm going to put the comparison function above all of my code but below the docstring because I prefer for functions to be defined before they're used. This is a function definition that we're creating, and it begins with the keyword def followed by the function name. We've already decided that the function name is compare, so def compare, and then I put parentheses with the parameter list enclosed. The parameter list will match the arguments that I passed in when I used the function, so it will be 2 integer values. I can call them whatever I want. I'm going to call them val1 and val2, and these are of type integer, which I will annotate here. I separate the parameters with a comma. So val1 colon int comma val2 colon int. After the closing parentheses of the parameter list, I'm going to annotate the return type. I do that by writing dash greater than with no space between, essentially an arrow, and then int, the type of value this function returns. Now, not surprisingly, I'm sure, there's a colon after the return type, and then the function body will be indented, just as with if statements and while statements. At the top of the function we write a docstring, and in a moment I'll show you the reason for that. Now, a docstring under a function heading should describe what the function does and what it returns. This function returns a positive integer if val1 is greater than val2, a negative integer if val2 is greater than val1, and 0 otherwise. We'll write a docstring describing that. Remember, a docstring is enclosed in triple quotes. Now with that written, we'll write the function. The simplest implementation is to subtract the second number from the first number and return the result. So I will return val1 minus val2. You will notice that return is a keyword. That function is written. A function can be much longer, of course. I can put any code in there that I like, but this function happens to be quite short. In fact, the whole program would be shorter if I never wrote the function at all, but the point of this program is to illustrate the syntax of a function, and I want to do that on a very simple function, so the focus is on syntax and nothing else. The syntax we want to focus on is the syntax of writing a function. So the keyword def, the name of the function, the annotated parameter list in parentheses, and then an arrow dash greater than with no space, and the return type followed by a colon. There's a docstring immediately after the function header which describes what the function returns. Then the function body, which is indented. That's the code that does the work of the function, transforming those input values into a meaningful result. Eventually, for most functions, there is a return statement at the end, followed by the value being returned. That might be an expression that evaluates to a value, as I have here. Val1 minus val2 will evaluate to an int value that is returned. Now the other syntax is invoking or calling the function, getting our function to execute. A function definition doesn't execute, it just associates the name of the function with the code. To get the function to execute, we have to invoke it. And we can invoke it as many times as we need, which is an advantage of functions. If there's some functionality that we need to use from many different places in our program, we should encapsulate it into a function so that we only have to write it once. Thus, we're less likely to make an error. So down in the executable code below the function definition, I have the function invocation, which simply uses the name of the function and the arguments to the function in parentheses. If the function returns a value, I want to do something with the value, such as assign it into a variable. So my function invocation looks like comparison equals compare open paren num1 comma num2 close paren. There's one other thing I want to do, and that's enclose the other code in this program in a function. So before my variable annotations, I'm going to write def main open paren close paren arrow none colon, and the keyword none begins with an uppercase N, you'll notice. I'll indent all the other code in the program under main. The function main will be where the program begins executing. To invoke main, because it takes no parameters and returns no result, I'll just write main open paren close paren at the bottom of the file. Now I have two functions defined, compare and main, and the first executable line in this program is a call to main. How does this all work? Well, let's run it and see. I'll give two numbers where the second is larger than the first. Think about all the ways you'd want to test this function. For example, suppose I give a negative number for my first number and a positive for my second. And the program reports correctly that the second number is larger than the first. And let me show you here in the console what happens if I type the name of my function compare followed by an open parentheses. A hint comes up. It shows me that the function takes two parameters, and it shows me the types of the parameters because they are annotated. It shows me that the function returns an int, again because I annotated that. And it shows me that docstring I wrote. So the programmer who uses this function knows how to interpret that integer result and what the parameters mean. All of that information in our function header and docstring is for the programmer using the function, as well as Python. Now the final bit of logistical information about functions is how they alter the flow of control. The default flow of control is sequential, top to bottom in the file. So our program begins executing, and the first thing it encounters is the compare function definition. The function gets defined, but nothing executes. This is the way a function name is associated with the code. The next thing it encounters is the main function definition, and again, the function is defined, but nothing executes. We then proceed to the first executable line, the call to main. We jump up to main and execute sequentially. We have the variable annotations and the input statements, and then we reach our function call to compare. On this line, control jumps up to compare. The value associated with num1 is copied to val1, and the value associated with num2 is copied to val2. They are associated by order, so it doesn't matter what I call these arguments or these parameters, they're matched in order by Python. Your argument list must have the same number of items as your parameter list. There's an exception, but we won't discuss that here. For now, if there are two parameters, you must supply two arguments, and they will be copied in order from the argument list to the parameter list. That means that compare has the values in val1 and val2 to work with as soon as it starts. That's how parameter lists work. They're variables that already have values when the function starts execution, the values copied from the argument list. The function executes and it returns a result. That result essentially replaces the function call down here where it was called. We return when the function ends to the function call, and this function call, compare num1, num2, evaluates to whatever is returned by compare. So if we pass in -10, 1, then compare returns -10 minus 1, which is -11, and compare num1, num2 evaluates to -11. That is the right side of this assignment statement, so that is then assigned into the variable comparison. It can then be used in the if, elif, else statement below. After the if, elif, else statement, the main function execution ends, and we return to the place where main was called. There's no more executable code in the file below the call to main, so the program ends. The return statement ends function execution. So if there were lines of code after the return statement, they would never execute. If there's no return statement, as in main, then the function will return to where it was called after the last executable statement, with a return value of none. It generally takes some practice getting accustomed to how functions work, particularly the passing of parameters and the returning of values. Previously in our programs, we had all of the variables available to all lines of code as soon as the variables were defined, and now we have a separate part of the program that can be communicated with, but only in well-defined ways. The functions can't and shouldn't use any of the variables in the context of the main program or the other function or functions, and the main program can't and shouldn't use any of the variables in the context of the functions. They are intentionally loosely coupled to keep functions as useful as possible. But that means that the only way the function communicates with the rest of the program is through the parameter list and the return value. Practice writing functions and working with the returned values until you can consistently write and use them effectively. For example, write functions to perform conversions, such as Celsius to Fahrenheit, pounds to kilograms, pints to gallons, etc., and invoke them from the main program with arguments and report the results. Once you can write functions with parameters and return values and use them in a program, you're ready to move on.